Hello, welcome back. We'll be continuing our discussion on antihistamines. In this video, we'll be talking about classification of antihistamines, and we'll see in detail about amino-alkyl ethers or ethanolamines. One example is mentioned in your syllabus, that is diphenhydramine. You need to learn about the synthesis of diphenhydramine, and also you need to know about dimenhydrinate. So we'll start our discussion on classification of antihistamines. As I had mentioned in the previous video, antihistamines are basically classified into first generation antihistamines and second generation antihistamines depending upon their period of discovery. So we have seen in the structural features of antihistamines that all antihistamines, especially the first generation antihistamines, are substituted ethyl amine derivative. So all the first generation antihistamines have certain common structural feature, and one of the important structural feature is the connecting atom. And depending upon the connecting atom present in these antihistamines, they can be again classified into, first one is amino-alkyl ethers or ethanolamine derivatives. Example is diphenhydramine. Then second one is the ethylene diamine derivative. Example tryptamine. Third one, alkyl amine derivative. They can again be classified into two types. Saturated analogues. Example is chlorpheniramine. Unsaturated analogues, triptolylene. And then the phenothiazine derivative. Example is promethazine. Piperazine derivatives. Example is cyclazine, chlorcyclazine, meclizine and buclizine. And then the last one is dibenzocycloheptenes and dibenzocycloheptanes. Example is cyproheptadiene hydrochloride and acetadine maleate respectively. So that is the classification of first generation antihistamines. And then coming to the second generation antihistamines, you can say that second generation antihistamines are a derivatives or more modified form of the first generation. They have somewhat similar structural features of the first generation. One example, they are again classified into piperazine derivative. Example is cetirizine. Pyridine and piperidine derivatives. Example is astamazole. And the third one is the dibenzocycloheptene derivatives or acetadine derivatives. Example is loratadine. And then there is entirely a third class of antihistamines. They are known as mast cell stabilizers or histamine release inhibitors. Example is cromolyn sodium. So that's all about the classification of antihistamines. Next, we shall discuss in detail about the first generation antihistamines. First, we'll see about amino-alkyl ethers or ethanolamine derivatives. I'll discuss about the chemistry and synthesis of diphenhydramine. So, talking about the chemistry of amino-alkyl ethers, they have a general structure ROR. They can also be considered as ethanolamine derivatives. And we have seen the general structure of all antihistamines, and in the case of amino-alkyl ethers, the connecting atom is CHO. So, oxygen atom is connected to the ethyl chain. This is the structure of diphenhydramine. You can see ether linkage, and at one end of the ethyl chain you can see a terminal nitrogen atom with two methyl group attached to it, which is common to almost all the first generation antihistamines. Then at the other end of the ether carbon atom you can see two aryl ring. Here it is two phenyl ring, so that is why the name diphenhydramine. Diphenhydramine is a oily liquid, lipid soluble oily liquid, and it is a base because it contains a nitrogen atom, and it is used as its salt form by reacting it with acids. The most common form is the hydrochloride salt, which is a white crystalline powder soluble in water. Now, if you look at the two structures given here, one is the diphenhydramine and the other one is the benzotropine. You can see some similar structural features. But benzotropine is an anticholinergic agent and diphenhydramine is an antihistaminic agent. They both share some common structural feature. The diaryl functional group, that is the diphenyl functional group, and the tertiary amino-alkyl ether structure. is common for both the diphenhydramine and for the anticholinergic agents. And therefore, the antihistamines also show anticholinergic property. And because of this reason, they exhibit antiemetic properties, antitussive properties, local anesthetic property, and smooth muscle relaxant activity. So the antihistamines can also be used as antiemetics in motion sickness as well as anti-Parkinsonian agents. The antimuscarinic action is responsible for the common side effects of antihistamines like dry mouth, blurred vision, urinary retention, constipation, and tachycardia. Diphenhydramine, being lipophilic, can readily cross the blood-brain barrier and can block the central nervous system H1 receptor, and therefore they are highly sedative or they can cause drowsiness. Now, what are the uses of diphenhydramine? So they are basically antihistaminic agents, and so they are used in allergic preparations against common allergic reactions like urticaria, hay fever. Then they can also be used as antiemetic, antitussive, local anesthetic, and also for their smooth muscle relaxant property. Then we'll discuss the synthesis of diphenhydramine. It is a two-step reaction. First step is the bromination of diphenyl methane. It is a free radical substitution reaction. Bromination takes place in presence of ultraviolet radiation. The hydrogen atom of the methyl group is replaced by bromine atom to form benzhydryl bromide. Then in the second step, substitution reaction takes place where it is treated with dimethyl aminoethanol to form the diphenhydramine. So that's all about the synthesis of diphenhydramine. Now we'll discuss about dimenhydrinate. Dimenhydrinate is diphenhydramine and 8-chlorotheophylline in equimolar proportions. So it contains, in addition to diphenhydramine, 8-chlorotheophylline. 8-chlorotheophylline is chemically a dimethyl xanthine. Xanthine derivatives like caffeine. Caffeine is trimethyl xanthine. So they have this CNS stimulation activity. They are CNS stimulant. So diphenhydramine, the main side effect of diphenhydramine is they are highly sedative. So when you combine with 8-chlorotheophylline, it is having some CNS stimulant action. So that sedative property or sedative action of diphenhydramine can be counterbalanced by the excitatory effect of 8-chlorotheophylline. And then next is that 8-chlorotheophylline and diphenhydramine. The dimenhydrinate is a crystalline odorless powder. They are highly soluble in water and they are soluble in alcohol and chloroform. And this dimenhydrinate is mainly used for their antiemetic property. They are used in motion sickness as well as in nausea associated with pregnancy, hyperemesis gravidarum, or nausea associated with pregnancy. So that's all about dimenhydrinate.